Hello, third graders. Today we're going to start talking about static electricity. Now, I know we've all had static electricity before, right? You have socks on and you walk across the carpet and you touch the doorknob and bing, you get shocked, right? That is static electricity. So what is static electricity? Well, the word static means stationary. It doesn't move. So static electricity is electricity that doesn't move, which is different from the next type of electricity we're going to learn about. So static electricity is electricity that does not move. It kind of builds up a charge, okay? Electricity comes from the word electron. So everything in the universe is made out of matter. We talked about that in second grade. Solid, liquid, and gas. And all of that matter is made up of teeny tiny little pieces called atoms. And atoms are made up of parts: protons, neutrons, and electrons. Let's take a look. Voila! Here are my atoms. Okay, so I'm going to start with helium. Helium is so great in balloons because it's really lightweight. It floats. And the reason that helium floats is because it's really small. It's number 2 on the periodic table of the elements. So let's learn about helium. All atoms, whether it's helium or plutonium, are made up of 3 things. They're made up of protons, neutrons, and electrons. Oh, electron. Remember, electricity comes from electron. So a proton has a positive charge. It has a plus charge. A neutron is neutral. It doesn't, I don't care, whatever, right? It does not have any charge at all. An electron is negative. It has a negative charge. It's a minus. This kind of makes me think about magnets. Do you remember when we looked at magnets, and magnets had a north and a south? Well, think about that kind of like as a plus and a minus, right? So now an electron, an atom kind of have like a north and a south. Instead of being poles, we call them charges. Plus charge and minus charge, okay? Electrons have a negative charge, a minus charge. All right, let's go take a look at carbon. All life on Earth is made out of carbon atoms. I'm made out of carbon, plants are made out of carbon, all the animals at school are made out of carbon, you are made out of carbon. So carbon is really important. It's a little bigger than helium. Helium is number 2, carbon is number 6, but it's still made out of the same 3 parts: protons, neutrons, and electrons. So carbon has 6 protons, 6 plus charges. Carbon has 6 neutrons, 6 neutral charges. And carbon has 6 electrons, 1, 2, 3, 4, 5, 6, 6 negative charges. So these have 6 positives and 6 negatives. This one has 2 positives and 2 negatives. Right now, those atoms are neutrally charged. They have the same number of pluses and the same number of minuses. Now, if I wanted to change that balance, I would have to take something away. And when I look at an atom, I'm thinking, which would it be easier to steal? Something down in the center of the atom, or the electrons which are flying around on the outside of the atom? Well, I'm kind of lazy, so I want to do the easiest amount of work possible. So I'm going to go for the electrons, because they're flying around on the outside of the atom. They're going to be much easier for me to take away. And that's what happens with electricity. You remove, or these electrons are transferred along, okay? So static electricity, when we talk about static electricity, we're talking about stealing the negative electrons, which are on the outside of the atom. Let's learn some more. Okay, now I want us to go to PhET. at the University of Colorado, Boulder. So phet.colorado.edu. And we're going to go to, you're going to see this website. You're going to go again to the by grade level. We're going to go to elementary school, click. And we're going to go down, down, down to where it says balloons and static electricity. I'm not going to download it. I'm just going to play it right off of the website. Okay, so do you remember how I said everything has plus and minus charges, right? The protons have a positive charge. The electrons have a negative charge. So all of this matter, this sweater, this balloon, the wall, all of them have plus and minus charges. Now, if I take this balloon and I can click on it and I can move it around, if I take this balloon and I rub it on the sweater, look what happened to the balloon. It took all of the minus charges off of the sweater and put them on the balloon. Let's think back about magnets. If I let go of the balloon, right now I'm holding the balloon in place. Whoops, I bumped the tripod. If I let go of the balloon, what do you think is going to happen? Let's think about magnets. If this was a North Pole and this was a South Pole, the rule is opposites attract. So if I let go, whoop, that's exactly what happened. The balloon, which has more negative charges than positive, was attracted to the positively charged sweater. Now, let's see what happens when we put this balloon over near the wall. Do you see what's happening? Look at that. You see how the negative charges are pushing away? There's like a force field around the balloon. Okay, I am going to reset. So now everything is back to pluses and minuses. Everything is balanced, right? Now, let's get two balloons. I'm going to have this balloon, whoops, I'm going to click on this balloon. I'm going to get a few electrons on it. And I'm going to take this balloon and I'm going to get some electrons on it. Okay, it's attracted there. I want to see what happens. Oh, this balloon has both of the balloons have a lot of negative charges. So this balloon is pushed away from this one because this one has a lot of negative charge. This one has a lot of negative charge. It's like having two North Poles. We know that the same poles repel. The same thing happens with balloons and charges. Two negative charges repel. But let's see what happens if we put this balloon over here. It's going to be attracted to the sweater. So this is a super fun little project to play with on PhET. So go to phet.colorado.edu and go to the balloons and charges and static electricity. Balloons and static electricity. This is a picture of a girl who went to Carpenter, and we were learning about static electricity. And we went out to the playground, and I had everybody slide down the slide. The slide acted like the balloon. It pulled a lot of extra electrons off of Sierra. Now her hair had a positive charge, and the slide had a negative charge. And as a result, her hair was attracted to the slide and looked totally cool. So this is a great example of static electricity.